When we think of disasters, we often picture earthquakes, volcanic eruptions, and devastating storms. But some natural hazards are much less visible. Take sinkholes, for example. These sudden depressions in the ground don't always make the news unless they swallow something big like a house or a highway. But sinkholes come in all shapes and sizes, and they're a lot more common than you might think. So let's get to the bottom of these mysterious geological formations. First, let's define our terms. What exactly is a sinkhole? Simply put, a sinkhole is a natural depression in the ground that forms when an underground cavity suddenly collapses. Now, this hole isn't just a pothole in the road or a rut in a muddy field. It's a feature of the landscape that results from the dissolving of rock beneath the surface. How does this happen? Well, it starts with water seeping into the ground. As rainwater percolates through the soil, it becomes slightly acidic. The exact chemistry varies depending on the local environment, but generally the pH of natural water is between 6 and 7, which makes it slightly acidic. That acidity is enough to begin dissolving certain types of bedrock, especially limestone, which is made up of calcium carbonate. When rainwater with a pH of around 6 comes into contact with limestone, a reaction occurs that breaks down the rock into smaller particles. The resulting solution flows into streams and eventually makes its way back to the ocean. There, the process reverses and the minerals precipitate back out of solution, forming new limestone. This cycle of erosion and deposition is a key part of the rock's life cycle, and it's what happens in caves as well. In fact, many underground cavities form in a similar way. When water seeps into the ground, it can dissolve the rock and create voids. Over time, these voids enlarge and can even connect to form vast networks of tunnels and caverns. Eventually, the roof of these underground cavities may become too weak to support the overlying soil and rock layers, and the whole thing collapses. And that's when a sinkhole forms. But not all sinkholes are created equal. Geologists recognize several different types based on how they form. Solution sinkholes, for example, result from the direct dissolution of bedrock by acidic water. Imagine a single drop of water seeping into the ground. As it makes its way through the rock, it slowly dissolves the limestone and creates a small void. Eventually, the roof of this underground cavity becomes too weak and the sinkhole forms. Other sinkholes form more gradually. In cover subsidence sinkholes, a layer of sediment known as the regolith covers a limestone void. This layer acts as a sort of protective cap, but it's still thin enough to allow water to trickle through and dissolve the underlying rock. Over time, the roof of the void grows weaker and the regolith above it begins to settle into the void, causing the surface to subside. This type of sinkhole doesn't collapse suddenly, but it's not a benign feature either. The slow settling can cause the ground to crack and shift, disrupting buildings and other structures. Then there are cover collapse sinkholes. As the name suggests, these form when the regolith covering a subterranean void collapses suddenly and dramatically. In some cases, this happens because of heavy rainfall or snowmelt that saturates the ground and makes it heavier. In other cases, the collapse may be triggered by human activities such as mining or drilling. Whatever their size or shape, sinkholes are a fascinating example of the power of water to sculpt the landscape. But where do these impressive geological formations occur most often? The answer is in areas where the bedrock is made of soluble rocks like limestone, salt deposits, and some carbonate rocks. In fact, entire regions can be shaped by the dissolving action of water, such as the famous karst landscapes found throughout the world. A karst landscape is a term used to describe a region dominated by sinkholes, caves, and other features formed by the dissolving of soluble bedrock. Some of the most impressive examples of karst terrain can be found in places like China, Chongqing City, and Florida's famed Everglades. These areas are characterized by a unique combination of caves, sinkholes, disappearing streams, and underground rivers. In fact, the word karst itself refers to a particular type of limestone formation found in these regions. These landscapes are so distinctive that they've inspired a subfield of geology dedicated to studying them. Karst hydrology is the study of how water moves through the unique subsurface drainage systems found in karst regions. In areas with lots of karst, water flowing over the land quickly disappears below the surface, making these regions challenging places to build and develop. The challenges are many, including not only the risk of sudden sinkhole formation, but also the difficulty of providing reliable sources of drinking water. But these landscapes are also home to some of the world's most beautiful caves and unique wildlife. So while they pose challenges for humans, karst landscapes are also a testament to the power and beauty of natural processes. But humans can also play a role in sinkhole formation. Mining, drilling, and other human activities can speed up the process of bedrock dissolution. For example, when water enters a mine shaft, it can dissolve the rock and create voids. Over time, the roofs of these underground cavities may become unstable and collapse, leading to the formation of sinkholes. And it's not just human-made voids that need to be watched. Natural ones can also pose a risk. Underground mining operations, oil and gas wells, and even irrigation ditches can all contribute to sinkhole formation by providing pathways for water to reach the bedrock. Even something as simple as a leaky water pipe can undermine the stability of the surrounding soil and lead to the formation of a sinkhole. That's because the water flowing through the pipes can seep into the ground and dissolve the underlying rock, creating voids that undermine the stability of the overlying soil. If the soil above these voids becomes saturated with water, it can lose its ability to support itself, and the sinkhole may collapse suddenly and dramatically. In some cases, these sinkholes can be catastrophic. In 1981, a water tower collapsed into a sinkhole in Winter Park, Florida, causing extensive damage to the surrounding area. And in 2013, a section of highway collapsed into a sinkhole near Tampa, Florida, forcing officials to close the road and find a way to repair the damage. But it's not always obvious when these hazards are present. Sometimes sinkholes form gradually over years or decades, while in other cases they can emerge suddenly without warning. That's why it's important to be aware of the signs of sinkhole formation and to take steps to mitigate the risks. For example, if you notice cracks in the foundation of your home, or if you see the ground around your property beginning to sag, it's time to call in a professional. A qualified geologist or engineer can assess the situation and recommend steps to prevent further damage. Sinkholes can be found all over the world, from Florida to China to the UK. In fact, no place is immune to these geological surprises. Understanding the science behind sinkhole formation helps us predict where they might occur and how to minimize their impact. Whether we re-exploring the caves and sinkholes of Florida, as Everglades, or the towering karst formations of China's Chongqing City, these natural wonders remind us of the incredible power of water to shape our planet. And while sinkholes pose challenges for humans, they also offer a unique opportunity to study the fascinating world beneath our feet. So next time you hear about a sinkhole in the news, take a moment to appreciate the complex geological processes that created it. Who knows? You might even learn something new. As you watch more clips from this channel, you'll start to notice connections between topics that at first seemed unrelated. That's because the world is a complex and interconnected place. And understanding those connections is essential to solving the big problems facing humanity today. Thanks for watching this video.